Hey guys, so in this video I'm going over lesson 2.3, graphs of radical equations. So if we zoom in on this first little section, this is what a radical graph looks like. It's kind of like if we took our quadratics that we learned in Unit 1. Our parent function was y equals x squared. If we rotated that quadratic to its side and only looked at half of it, so only looked at this part, well, that's what we get. This little half u on its side graph. Now, parts of this graph. It is going to slowly, and I'm going to erase this for a second. It is slowly going to get really, really close to x is 0. But it's not actually going to cut it, or actually going to touch it. But it is going to go down forever. So if you want to make a note here, you can. Down forever. Not touching x equals 0. So the graph has restricted domain. So it's no longer going to be negative infinity to positive infinity. It is no longer going to go left forever and right forever. It is also, just like our parabola, is going to have a restricted range. So graphing radical parents, so the radical parent function is y equals the square root of x. So that parent function, we're going to draw, and actually it's already drawn for us, but we are going to make a table with our x and y values. And every single time I'm going to use these same 5 x values and same y values. Same 5 y values for a parent function. So it's going to be negative 1, 0, 1, 4, and 9. Every single time. Now, if we go to Desmos.com, we can get our y values at those points. So we got y equals square root x. That's our parent function, where x is negative 1. Well, negative 1 is way over here. There's nothing there. So on our paper or in our notes, we're going to write error. Where x is 0, y is 0. Where x is 1, y is 1. Where x is 4, y is 2, and where x is 9, and hopefully you can see a little bit better than I can. I have fat fingers. But where x is 9, y is 3. So we're going to use this to transform it depending on what our new equation looks like. So let's look at number 1. And number 1, we're first going to deal with our parent function, which is -1, 0, 1, 4, and 9. Error 0, 1, 2, 3. With this, we can see that we have a 2 on the outside. Well, if we have a 2 on the outside, are we affecting the x's or the y's? Think about the saying, if you like the saying from our transformation lesson from last unit. If we're on the inside, we're crossing our arms, kind of like we're mad at our parents. If we're on the outside, think about YMCA little dance. We're on the outside, we're getting patted on the head. We're affecting the y's. So this 2 is on the outside, affecting y's. So we're going to be dealing with these y values. Also know that it's multiplication in between. So we're going to come in here and multiply by 2 to get all of our values. So that means our new equation, which is y equals 2 times x squared, or square root of x, gives us error, because error times 2 is just error. 0 times 2 is still 0. 2 times 1 is 2. 2 times 2 is 4. And 3 times 2 is 6. So fill in our x values. They are no longer -1, 0, 1, 4, and 9 for sure. We've got to look at it and say, okay, is there anything on the inside with the x that would affect our x values? There isn't. So we would have our -1, 0, 1, 4, and 9 still. So if we wanted to graph this, we would have -1 error, which is nothing. 0, 0, 1, 2, 4, 4, and 9, 6. So it'd be right about here. Our graph would keep going. Versus our parent function, if you wanted to put it on the same graph, you would have 0, 0, 1, 1, 4, 2, and 9, 3. So about right here. So if we have a 2, or if we have an A, if we have an A that is greater than 1, it's going to get wider. That curve is going to get wider. If our A is less than 1, it's going to get skinnier. It's going to get closer to that x-axis. So in this case, A was greater than 1, so it's going to compress still, kind of like we did with our quadratics, with our parabolas. If it's less than 1, it's going to stretch. It's going to get closer to the x-axis. Let's do some other ones. So let's look at if A was less than 1. Still going to start with our parent function, and we had it as blue. So -1, again, parent function, square root of x. We got -1, 0, 1, 4, and 9. The reason why I always use those 5 x values is because it gives you whole numbers for your y values. So you can deal with them much easier. I forgot a 0. Hold up. Now the new one, we got y equals 1/2 times square root of x. 1/2 is on the outside, so we're affecting the y's. So we're going to come in here and multiply by 1/2. Multiply by 1/2. 1/2. 1/2. 1/2. So nothing on the inside with x, so we've still got -1, 0, 1, 4, and 9. And error times 1/2 is still error. 0 times 1/2 is still 0. 1 times 1/2 is 1/2. 2 times 1/2 is 1. And 3 times 1/2 is 1.5. So if we look on our graph, we can do our parent function first. So 0, 0, 1, 1, 4, 2, and then 9, 3. About right there is our parent function. And then our new function looks like this. 1.5, 4 and 1, 9 and 1.5, so about right there. So it got skinnier, it got closer to that x-axis. So what if there's a negative out front? Hopefully we remember, if there's a negative out front, you reflect it. You flip it over the x-axis. It's also on the outside, so it's not going to affect the x's, it's going to affect the y's. So our parent function, -1, 0, 1, 4, and 9 every time. Always have error, 0, 1, 2, 3. Also, hopefully it's easy to remember that 0, 1, 2, 3 part for the y's. New equation, y equals negative square root x. Negative out front, affecting the y's, and multiplying. So we're going to come here and multiply by -1, multiply by -1, multiply by -1, multiply by -1, multiply by -1. So nothing on the inside, so we still have the original x values. We have error times -1, it's still error. 0 times -1 is still 0. 1 times -1 is -1. 2 times -1 is -2. And 3 times -1 is -3. So our parent function, still that 0, 1, 1, 4, 2, 9, 3, there. And then our new equation is that 0, 0, 1, -1, 4, -2, and that 9, -3. So just a mirror over the x-axis. So we've already talked about the negative a on the outside. It's going to reflect. Technical words for it is going to reflect over x-axis. I will take flip if you put that on your check-in. So label the directional shifts for the equation of the radical equations. Equation of the radical equations. So remember, our A is going to determine if it stretches or compress. If it's negative, it's going to reflect. Inside is going to tell us left versus right, because it's affecting the x's just like the x-axis is left to right. And then the K out back is going to tell us up versus down. So let's look at some of these. So you can read these. This is just reminding you the translations or the transformations. For number 1, we're on the inside. So that means we're affecting the x's. That also means we're going to be disobedient. So instead of going on the x-axis, where our typical positive values are on the right, typical negative x values are on the left, we're going to go the opposite way from the negatives. So we're going to go to the right 2. So parent function, as always, we've got y equals square root of x. So square root of x, parent function, -1, 0, 1, 4, and 9. And then we have error, 0, 1, 2, 3. So when you are determining what you do in your table, just worry about looking at the shift description. Do not look at the actual equation. It will mess you up. It will mess you up. So first thing I want to do is determine, is it affecting my x's or is it affecting my y's? It's only affecting my x's because it's on the inside. So all of my y's are going to stay the same. Now if I want to move my parent function, which is here, if you need a visual, if I want to move this graph to the right 2, do you think I'm going to add or subtract 2 from all of my x values? I'm going to add it. So I'm going to add 2 to all of these x values. So that means I'm going to have -1 plus 2 to give me 1. 2 plus 0 gives me 2. 2 plus 1, it gives me 3. 4 plus 2 gives me 6. And 9 plus 2 gives me 11. So my new graph is going to be 2, 0, 3, 1, 6, 2, and then 11, 3. So push somewhere over here. And that's going to be my new graph. All right. So what if I have something on the outside, out back? So shift change, this is on the outside. So that's going to affect my y's. And we're being obedient to the sign. So if you do your y axis, positive y values are typically up, negative y values are typically down. So we're going to be going up 3. As always, parent function, y equals square root of x. Y equals square root of x. Same x value, same y values every time. I do want to warn you, if you go to another teacher during this lesson, aka during Monday or Tuesday, they may teach you different. It's okay. I teach you this way. So -1, 0, 1, 4, and 9. Then you have error, 0, 1, 2, and 3. So outside, affecting the y's. If you really want to, you can go ahead and do this graph. Alright. So this new graph, we've got square root of 3, or square root of x plus 3. It's on the outside affecting the y's, so all of my x's are going to stay the same. My y's, however, I'm going to move up 3. So if I want to move up 3, I'm going to add 3 to all of my y values. So error plus anything is still error. Actually, I want it red. 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. And 3 plus 3 is 6. So our new graph is here. 1, 4, 4, 5, and 9, 6. So that's my new graph. Moved up 3. Alright, so what if we have multiple transformations going on? So I want to do, it doesn't really matter, let's do this one. Our negative tells us to reflect or flip. Our -2 tells us to move to the right 2. And our +3 tells us to go up 3. So our parent function. Dealing with our parent function, setting it up for us so we can actually see how it transforms. Then error 0, 1, 2, 3. And if you really want to, you can always plot it. So our reflect, our negative outside, out front, outside, affects the y's. So I gotta come in here and multiply by -1. Then I've got my right 2. If I want to move left or right, it's on the inside affecting my x's. So if I want to move right 2, I'm going to add 2. lastly, up 3 is affecting my y's. It's on the outside. So I'm going to do add 3 to all of my y values. So I'm going to write off to the side in purple what I'm doing. I'm going to zoom in a little bit so I can show you. I've got -1 plus 2 to give me 1. I've got 0 plus 2 to give me 2. I've got 1 plus 2 to give me 3. 4 plus 2 to give me 6. And 9 plus 2 to give me 11. And then for my y's, I've got error times -1 plus 3 to give me error. I've got 0 times -1 plus 3. Well, 0 times -1 is 0. So 0 plus 3 gives me 3. I've got 1 times -1 plus 3. 1 times -1 is -1 plus 3 is 2. 2 times -1 plus 3. Well, 2 times -1 is -2. Then plus 3 gives me 1. And then 3 times -1 plus 3. -3 plus 3 gives me 0. So that would be my new graph, my new equation. So we've got 2, 3, which is there. We got 3, 2, which is there. 6, 1, which is there. And then 11, 0, which would be way over here. So that would be our graph. All right, so remember, as you take these notes, you're going to come to class ready to ask questions about this. Hope you guys have a good night.